Hello, everyone. Welcome to today's webinar, Pioneering the Future of Cloud Native Deployments with Titanium. I'm Deboshri Sarkar. I'm the head of marketing here at Titanium platform, and I'm thrilled to be your host today. Joining me today as my co-speaker is Jesus. He is the lead technical solution architect at Titanium with extensive expertise in 5G signaling core and a background in roaming business and signaling core networks engineering design and operations from his tenure at Vodafone. Jesus brings invaluable insights to our team. We are very excited to have him today and share his detailed insights about our cloud native platform. So here's an overview of our agenda. We will kick off our discussion by exploring why cloud native deployments are essential in today's digital landscape and the challenges they address. Next, we will dive into how our cloud native platform, Titanium, bridges that gap between traditional and cloud native deployments, enabling organization to transition seamlessly to modern architectures. Then Jesus will deep dive into Titanium's architecture, the new feature on Titanium, which is the automated certificate management, use cases and case studies, the future perspective, and finally, we'll open the floor for the questions, for your questions. So please feel free to add in your questions in the Q&A chat window. We will address them at the end as per the time permits. If we are unable to address any of your questions, our team will reach out to you. Also, I highly encourage everyone to reach out to us with any question. Our team will be very happy to help you. So with that, let's go ahead and let's get started. All right. So let's look at why there has been this need for cloud native deployments and what are those roadblocks in the traditional deployments phase. The traditional deployments, we know that often face the scalability limitations due to their monolithic architecture and reliance on very static infrastructure, right? And we also see that traditional deployments are characterized by rigid architectures and very lengthy deployment cycles, making it very difficult for organization to really respond very quickly to market changes or any technological advancements. Again, there is this challenge with resource utilization. There is very inefficient resource utilization, which often leads to underutilized hardware resources and also results in increased costs. Again, we have seen traditional deployments struggle to adopt to the evolving technologies and the changing market demands, and due to basically just due to their static nature and the legacy infrastructure. So when we talk about cloud native, right? So what are those principles and um, of cloud native deployments, and this is something that we wanted to highlight, and these are the highlight principles. Firstly, it is embracing the microservices architecture, which is fundamental, and by breaking down applications into smaller loosely coupled services, we enhance that agility and scalability, enabling rapid development and deployment cycles. Next is the containerization, which plays a very pivotal role in the cloud native approach. And by encapsulating applications and their dependencies into lightweighted containers, we achieve that stability and portability across diverse environments, ensuring that seamless deployment and operation. Furthermore, adopting DevOps practices is essential for continuous integration and deployment. And this approach basically streamlines the development workflows, facilitating a faster iteration and feedback loops, ultimately accelerating the time to market for the new services and features. The dynamic orchestration is another key principle. By dynamically allocating and managing resources based on the workload demands, one can optimize resource utilization, ensuring that cost efficiency and performance optimization. And we have seen that with traditional deployments, these, each of these have been like the challenges, but with cloud native, I mean, these are, the basic principles of the cloud native. Moreover, implementing infrastructure as code enables automation and flexibility in the infrastructure management. And basically, this approach empowers us to provision and configure resources programmatically, reducing the manual intervention and minimizing the risk of the errors. Lastly, very important, we ensure the exposure of network and service assets through standard APIs. And by exposing the services through standard interfaces such as network APIs, we enable seamless integration with other systems and services, facilitating interoperability and collaboration. So now that we looked at the cloud native principles, what are the benefits, right? First and foremost, it enhances agility and flexibility in application development and deployment that we have already seen because of the the principle that they follow with microservices architecture and DevOps practices. We can quickly adapt to the changing market demands and deliver innovative solutions with ease. Um, Furthermore, the cloud native approach offers improved scalability to handle fluctuating workloads efficiently. By leveraging the containerization and the dynamic orchestration, we can seamlessly scale our applications to meet the growing demands, ensuring that optimal performance at all times. In addition, the distributed architecture enhances the resilience um, and the fault tolerance. So by decoupling, the services and deploying them across multiple nodes, we are able to minimize the impact of failures and ensure that high availability of our services. Moreover, the cloud native approach accelerates the time to market, and which we have already discussed, and is also one of the top benefits, and also the deployment cycles. With automated workflows and infrastructure as code, we can iterate quickly, delivering new features and updates to the market faster than ever before. And lastly, and very important, cloud native approach enables the cost optimizations through resource efficiency and pay as you go model. And by dynamically scaling resources based on demand and automating the infrastructure management, we can maximize the resource utilization and minimize the cost. Um, so how let's look at how titanium is basically bridging that gap, right? So uh, at its core, our cloud native platform Titanium is an intergenerational cloud native framework that empowers the carriers and operators to seamlessly transition between legacy and next generation 5G services. This innovative platform allows them to run both legacy and 5G services on a very cloud native infrastructure of their choice, thus offering them this unparalleled flexibility and scalability. So the range, you can see on this slide, is the range of cloud native applications that are deployed on Titanium, that spans from the selected application migrated from the our Titan platform, over to 5G core network functions like the network repository function, service communication proxy, security edge protection proxy, and many more. And Jesus will be giving us a very detailed dive into each of these areas, and also into the architecture framework of our Titanium platform. So just very quickly, let's go over some of the features and capabilities. These are, the identified top highlight features and capabilities. So firstly, at the heart of Titanium platform, it lies its intergenerational framework designed to seamlessly integrate legacy and 5G services. And this innovative framework ensures that the carriers and operators can transition smoothly from traditional systems to the cutting edge world of 5G, all within a single platform. Moving on, Titanium boasts a robust cloud native infrastructure that streamlines operation with automated deployment and management. This means that the carriers can efficiently deploy and manage their services, saving the time and resources while ensuring that optimal performance. That is very important. A critical aspect of Titanium platform is its certificate management automation, which is our newest feature on this cloud native platform. By automating the entire certificate life cycle, Titanium enhances operational efficiency and minimizes the risk of errors, ensuring smooth and secure operations. Again, Jesus will give us a very good deep dive into our certificate management automation feature on Titanium. So, moreover, scalability and self healing are inherent features of the platform. Titanium scales effortlessly to meet the growing demands and is designed to autonomously heal from failures, ensuring uninterrupted service delivery. Furthermore, Titanium offers support to both telco and hyperscale clouds, providing carriers with the flexibility to choose the cloud infrastructure that best suits their needs. This was versatility ensures compatibility across diverse environments, future proofing the operations for many years to come. Lastly, the Titanium platform hosts a diverse range of cloud native applications that we have seen in the previous slides, from legacy applications um, that actually migrated from the previous platform, which is our Titan platform, to the cutting edge 5G core networks functions. So this comprehensive suite of applications further enhances the platform's capabilities, offering the carriers and operators a complete solution for all their telecommunication needs. We definitely think that the Titanium platform is a game changer in the telecommunication industries, offering a wide range of versatile solution to basically navigate all the complexity of legal system, and it also provides an opportunity to embrace the 5G innovation. So with that, I will hand it over to you, Jesus, to give us a very detailed deep dive into each of these areas and share many more valuable insights. So over to you, Jesus.
Thanks. Thank you, Devosri. Yeah, I will just continue with the presentation. Um, yeah, so before talking in detail about our cloud native Titanium platform, it's important to start describing the background of our company when it comes to the concept of unified software platform. Um, Titanium Company is a provider of signaling solutions in the control plane of operators' core networks. Right? Traditionally, we've been offering our products on top of our virtual software platform called Titan, with which we have transformed the concept of core signaling, modernization, and consolidation in the industry. Titan hosts all our solutions in the area of 2G, 3G networks, 4G, IMS, or customer-defined applications. This expands also within the domains of signaling security and routing, subscriber data management, or access and session management. Now, back in 2018, 2019, it became fully clear for us that the different industry trends were pushing us towards evolving our existing Titan virtualized software platform to a new cloud native software platform called Titanium. This new platform should be able to address all the new industry trends, the mobile generation evolution, and the new requirements in the telco business. One of the key drivers for pushing Titanium towards the new cloud native platform is definitely 5G. When approaching 5G, it was clear for us that we would concentrate on the specific domains of the 5G standalone core that are related to the signaling, routing, and signaling security. These are key areas where Titanium excels and provides full expertise. But in order to provide the required capabilities that 5G solutions mandate, the adoption of cloud native infrastructure is mandatory. 5G poses new challenges above and beyond a new protocol specification. 5G introduces concepts like security by design, and unlike legacy mobility, 5G is a distributed system that requires fast, low latency data replication. Solutions must be also multi-vendor friendly, and due to the sheer number of additional devices and services, it needs an unprecedented scale. Um, while 5G appeared as the main driver in the telco business towards cloud native introduction, it's not as simple as just deploying 5G only. Our customers have multiple generations of mobility solutions, and some of them also need to make the migration. Multiple generations of functions must coexist using unified operations. Solutions must be open and flexible so that they can use the same resources and tooling, reducing operational silos. Solutions must also have a degree of flexibility built in to accommodate for multi-vendor environments. Um, and then, covering this third item, automation is impacting every piece of our customers' business, ordering, developing, deploying, and interacting with a long list of vendors. So vendors need to be able to adapt and enable this automated evolution. This leads to a complete automation of the solution development, integration, and deployment, as well as feedback loops into their multi-vendor ecosystem. Operators are integrating their CI/CD pipelines with the existing suppliers, and the customers need open, customizable, and flexible solutions that can integrate into their GitOps workflows. Taking all of this into account, we built Titanium platform that embraces all these new concepts by providing a common tool for cloud native solutions provided by Titanium. So as a quick summary to make sure that we are aligned for the rest of the presentations, uh, we can say that Titanium as a company offers its product portfolio in two different software platforms. We have Titan-based products for physical or virtualized network functions, and then we have the portfolio of cloud native network functions based on Titanium cloud native platform. Then as supplementary solutions, we have element management system and analytics products that can sit on top of both Titan and Titanium based products. In the session today, we are focusing on Titanium cloud native software platform. So with this slide, let's try to get an overall picture of what is being offered with Titanium platform. Titanium can be considered as an internal telco platform as a service used for our own development of network functions. These network functions are within the domain of signaling control plane in the core network. Titanium is meant to provide all the common capabilities that all these network functions will require. Centralizing these common features at the platform level allows for shorter application development time, easier scalability, and unified user experience. The portfolio of CNF products available in Titanium platform expand through the 5G signaling, routing, and security domain, where we have SCPP, BSF, SCP, NRF, and NSSF. And the 2G, 3G, 4G signaling routing and security domain, where we have the signaling firewall available for both SS7 and diameter protocols. And the access and session management domain, where we have Enum DNS and UT proxy products. As you saw in a previous slide from Debosri, more products will become available as CNF in Titanium in the near future. What this diagram is showing is that all these different NF products benefit from using common platform services, data services, or network services that are provided by the underlying Titanium Cloud Native platform. We'll see it in more detail in the next slide, but this means that aspects like providing distributed data management and storage, or open APIs for operation and maintenance, or certificate lifecycle management are capabilities that are not required as part of the NF development, but maintained in the common level of Titanium. With our network functions being fully focused on signaling in the control plane, the management of the signaling stack is also made available by the platform to the different network functions. Titanium also allows the application to be data-less microservices, enabling scalable compute for the network functions. In summary, when you get a particular product from our portfolio, let's say 5G SEP, the solution you get is the combination of the SEP-specific application microservices together with the full set of capabilities provided by Titanium as the underlying cloud-native platform. All together, provide the complete capabilities of SEP as a network function for your core network. Let's have a closer look to the services that are offered by Titanium as a platform. The set of microservices forming Titanium are a combination of Titanium's internal research and development activities, together with the selection of best-of-breed open source technologies massively adopted by the industry for cloud-native solutions. The selection of these open source tools allow Titanium to focus and rapidly innovate in our core expertise, while taking benefit of the solutions already implemented for common needs and problems in the cloud-native landscape. It also reduced adoption times and led to an open solution that benefits customers. Standard interfaces reduce complexity, avoid vendor locking, and empowers flexibility. Titanium offers data management services for both OEM data and NF data, taking care of its availability, storing, replication, or exposure together with APIs. The solution reuses Apache Kafka technology as open source, publish, subscribe, message bus system, enabling low latency, high throughput data replication. Titanium also takes care of authorization, incorporating Keycloak, an open source CNCF project for identity and access management. Each Titanium cluster also offers a telemetry suite where the different statistics, alarms, event logs, traces, or transaction detail records generated by Titanium platform or by the application microservices are consumed by the telemetry suite for them to be visualized in OpenSearch dashboards. In terms of monitoring and observability, Titanium also provides for metrics collection and exposure, facilitating the integration with the underlying cache infrastructure in aspects like horizontal pod autoscaling decisions, incorporating Prometheus. From administration services point of view, Titanium offers 3 different graphical user interfaces covering OEM, telemetry, and identity management. On top of that, Titanium also offers REST API for configuration and provisioning, enabling for automation capabilities. Titanium provides for a common, centralized, and unified OSS integration toolkit for the different network functions that could be deployed on top of it. Several options are provided for a flexible OSS integration. Titanium also offers accounting service with the generation of TDRs, transaction detail records, and it also allows for integration with external probing or analytic solution by exposing these TDRs or with the virtual tab traffic mirroring feature, which is based on gRPC interface and available for the different 5G products. Finally, on the networking services side, Titanium provides the signaling stacks like HTTP, HTTP2, diameter, SS7, or DNS that are required by the different applications. It also covers aspects like certificate management, certificate lifecycle management that we will explore in more detail in this session, or service mesh. Yeah, some of these services may be optional or only applicable to certain subset of Titanium CNFs, but this is a complete set of capabilities that the platform is offering. Yeah, I'm talking now on how a Titanium-based product is deployed on the cloud infrastructure. This diagram shows how such a deployment look like. Our cloud-native applications are composed of microservices packaged in portable containers, operated horizontally and scaled independently. Titanium runs network functions as containerized workloads managed by Kubernetes. Now, it is important to highlight that Titanium is not a provider of CaaS infrastructure. Our deployments will be done on customers' provided CaaS or potentially a partner's provided CaaS. And the philosophy we took is to embrace multi-CaaS support. Developing Titanium as much CaaS agnostic as possible allowed us to focus on flexibility and customizations that would allow Titanium to be deployed on any CaaS environment belonging to private, public, or hybrid clouds. The CaaS environment examples shown in this picture correspond to some of the experience already collected in Titanium's deployments. The experience includes also private CaaS environments developed by the customers themselves based on upstream Kubernetes. And we have also seen increasing interest in open source Silva CaaS for telco cloud. So we are really embracing this idea of the multicast support and being open to customize any specific aspect that could require for particular deployments. On top of all this, we can also provide automation capabilities in terms of CI/CD services or GitOps integration. We'll show an example of this in the next slide. I will describe the microservices architecture in a Titanium 5G CNF, and this will serve as introduction for the certificate management feature to be discussed in next slides. The underlying Titanium platform provides platform as a service to the NF application, and the Titanium's microservice called Data Store offers data as a service to these applications. With this approach, the application microservice or microservices become dataless compute components, implementing the business logic of an off-the-shelf application or a customer-defined application. In many of those NF applications, when it is required, there is also dedicated microservice for signaling routing management. With 5G, there should always be a trade-off between low latency and massive scale that could drive the architectural decision around implementing dedicated microservice for signaling networking. When service mesh is required, there will also be a layer 7 load balancing towards the application microservices. In order to implement mutual TLS on HTTP2 signaling, the routing or the service mesh microservices will need to manage one or multiple local identity leaf certificates and one or multiple trusted certificate authorities. And applications need to implement the required logic to utilize the right certificate at the right time. Management of these certificates with a Titanium cluster can be done in a manual or an automated way, as we will see in the next slides. So certificate management is not only related to 5G, since it is also applicable to every internal secure communication between microservices, to integrations with external OSS systems, or the access to web graphical user interfaces. but in any case, its importance scales to a whole new level with 5G NFs, where mutual TLS is required in the HTTP2 signaling. I show here the default approach for manual certificate management. This is used generally as a starting phase in most deployments where the customer operator is not yet ready with its PKI solution, the public key infrastructure, for an automated integration. Here, the initial generation of the required CSRs, certificate signing requests, and the signing of these CSRs by the certificate authority to generate the TLS certificate is done as a manual exchange as part of the initial deployment and instantiation of the CNF. Whenever new certificates are to be added or existing certificates have to be renewed, changes will also be introduced manually based on a new deployment activity through updates in the O&M user interface or updates on the OM agent via REST API interface. In all cases, certificates are added through kubeAPI server into the Kubernetes cluster and stored in etcd as a secret, being also mounted into the local ephemeral volume of the concerned application pod that requires them. So this is showing how the different activities related to the certificate management have to be done in a manual way. Here we are showing the approach introduced with automated certificate management feature. As commented before, in many deployments, this is being considered as a phase 2 activity, starting with a manual approach, but with solid plans to move towards an automated integration. In this case, the generation of certificate signing requests, the communication with issuing CAs, the generation of the certificates and its storage and availability within the concerned pods is automated. More important, the renewal of those certificates before its expiration date is also done in an automated way. This enables the generation of certificates with shorter validity periods, enhancing security. The main security requirement here is that certificates should be automatically updated on a very frequent basis with no administrative burden. This capability has been achieved by allowing the integration of Titan.ium with the CNCF incubating project called Cert Manager, which automatically provision and manage TLS certificates in Kubernetes. It is a certificate lifecycle management solution, and it can integrate with the issuing CAs, being local CAs as a Kubernetes secret, or external CAs, which could be HashiCorp Vault CA, any CA via Acme protocol, or any other CA via custom integration plugin. During the initial deployment of the Titanium cluster, you will specify certificate resources and issuers with the relevant input data. And starting from the initial deployment, Cert Manager will be in charge of certificates generation and renewals. Titanium can utilize Cert Manager as a service provided by the service operator or by the cloud infrastructure provider. But if not available, Titanium can also deliver Cert Manager as part of our solution deployment. It is important to highlight here that Titanium is not a PKI. Public infrastructure is to be provided by the customer, and Titanium will integrate with it through Cert Manager. I will use the next slides to show some Titanium real use cases in more detail. So in this slide, with this example, we try to show why automated certificate management becomes a very important feature in 5G NFs, and specifically in 5G SEP product, which is sitting in the edge of the PLMN or in an IPX or roaming hub entity. SEP, Security Edge Protection Proxy, will need to manage several different NF certificates for its TLS communications. It will need at least one for the internal communication towards the 5G core service-based interface, and at least one for the external communication towards remote PLMNs or IPXs in the N32 interface. In some cases, it will also be required to have different certificates when acting as client or as server, and in some situations, there may also be different TLS identities within the same NF. On top of that, there will be TLS certificates related to the intra-NF communication for the secure TLS encrypted communication between NF components and microservices within the Kubernetes cluster. All these different certificates will need to be issued by different issuing CAs belonging to different root CAs, and all of them could have different expiration times. This shows that at a certain point, manual certificate management will not be feasible anymore. This diagram is also illustrating that in the case of SEP, and in order to have successful TLS connections over N32 interface with remote foreign PLMN or IPX SEPs, it will be required that the public certificate of the root CAs used by the remote roaming partners are stored locally in my SEP's trust store, identified as trusted root CAs. GSMA is proposing this concept of bilateral trust model, requiring this root CA exchange between remote PLMNs or IPXs for enabling 5G roaming interconnection. While previous slides were more focused on Titanium's architecture and platform capabilities, with this second use case example, we show the potential in terms of automation as part of the deployment of Titanium CNF products. As part of a new release of a Titanium product, the relevant software artifacts in terms of containers and health charts will become available. And these artifacts can be pushed to the software repository within the customer CAS. Many of our customers are embracing CI/CD, automation, and GitOps, and are using open source CNCF tools like Argo CD or Flux CD to run workflows and manage Kubernetes clusters, and are using Git as a distributed version control system and single source of truth. What we can do in Titanium is that we can feed Git also with declarative specifications, YAML files, containing the relevant override values related to the deployment, particular CAS adaptations, certificates, inputs, and configuration. And in this way, when Argo CD is pulling a release to be deployed on the existing Kubernetes cluster of the CAS environment, it will be able to deploy a CNF that comes up and is immediately ready for service. Right? The deployment is always on and delivers virtually zero-touch operational experience. Right? Good. So I will finalize with a quick summary on Titanium platform. We can highlight that it comes as the solution for building 5G NFs and covering its new requirements like distributed low latency, data replication, and massive scaling. It becomes our solution for cloud native deployments, extending not only to 5G, but also to legacy applications that are requiring an infrastructure modernization. It also becomes the perfect fit for embracing automation and GitOps integrations by using open APIs and a rich ecosystem of tools. And finally, by offering multicast support, it provides flexible deployment models and customizations as required by each customer. I will close with a final view on Titanium's platform future evolution. Well, Titanium platform is in constant evolution and should embrace the new industry requirements, right? An important area of development is related to increase the automation, autonomy, and sustainability of Titanium CNF deployments. One of these areas of research is related to test automation. We are following activities like CNTI test catalog, Cloud Native Telecom Initiative, as a tool that validates telco applications adherence to cloud native principles. The concept of network as a service and network exposure via APIs is broadly being discussed within the industry, and in our case with our customers, for identifying a specific use case that that may be identified, and then working on proof of concepts that could demonstrate those use cases. Um, Aspects like network slicing or artificial intelligence or post-quantum cryptography are being researched internally also as areas in the industry that could have an impact, and where we will need to stay up to date with them. And finally, there are aspects like this Web 3.0 or blockchain that could be related to obtaining independency from regulatory agencies. But it's important also to consider aspects like lawful interception that is specifically relevant in the telco industry. So they remain also as research activities. Internally, we will keep exploring all these potential enhancements for our solution so that Titanium platform evolves accordingly with the industry requirements. So yeah, that's it. I think I could hand it over back to you, Debosri, for the Q&A session.
All can hear me?
Yes.
Okay, great, great. Thank you so much, Jesus. Very, very informative presentation. Yeah, so let's go ahead and let's look at the questions. I see a lot of good questions coming in. So let me just quickly scroll through all the questions. And like I said, if we are unable to take your questions today, our team will reach out to you. So yeah. Um, so let's take this first one. What existing products on Titan is not yet available in Titanium uh, and will come next? Um, yeah, I think this is a very nice question actually. Jesus, would you like to take this question?
Hmm. Yeah, sure.
Yes.
Yeah, so basically, we have been evolving several Titan applications, Titan products, to become available in Titanium already. That's the case for signaling firewall, in DNS or UT proxy. We are working already on the DSC diameter signaling controller for DRA and DEA functionalities. That is our next product that should become available on Titanium. Work is being done to achieve this goal. In terms of additional network functions that could become available, we are initiating activities on several directions. We plan to facilitate customer-defined applications that are currently available on Titan, so that they can also be available on Titanium in the near future. And yeah, some specific applications like number portability could also be considered for these next steps in the adoption of Titanium platform.
Great, thanks, Jesus. So I think that since we mentioned about the APIs, I think that this next question actually is related to that. Are you planning to provide network exposure APIs on Titanium? Jesus, do you have any insights on this?
Hmm. Yeah, it's a good question. I think this is yeah, this is a key area for research. So definitely there are a lot of conversations with different customers on network exposure. I think at this moment it's also about identifying the real use cases. There is a lot of potential in this capability network exposure, APIs that could be used by the customer for exposing data collected by our ONFs, enabling new services by reusing this data. So this is an area that we are exploring and we are discussing with several customers, and we have potential um, proof of concept activities that should be triggered for enabling some specific use cases around this feature.
Great, thank you. Okay, I'm just taking some time to actually scroll through the questions that we received to see if we have really we can pick up some really nice ones. So yeah, I can see one question which is about more information on the 5G solutions that we had on our Titanium slide. The solutions that are deployed. So yeah, I can actually take up this question. We do have a lot of information about all the 5G solutions that we offer on our website. And what we would highly recommend is getting in touch with our team, so that we can actually give you a great overview of what we have in depth, how our 5G solutions can help your organization as per your needs. So yes, do visit our website, and also reach out to our team so that we can help you out better. Um, so the next one is automated certificate management feature mainly considered for 5G products? I think this is a very good question. Jesus, do you want to actually take this one?
Yeah, sure. Yeah, so definitely it's not only applicable to 5G products. In any titanium CNF solution, or there will be usage of certificates, TLS certificates. Many of them are related to O&M interfaces or OSS interfaces or web UI interfaces, and it's a common requirement from cybersecurity teams in operator side that yeah, the management of those certificates may also require an automated integration with the CA for these issuing and renewals of certificates. Now, what happens is that while those integrations for certificates are purely on the operation and administrative side, when we move into 5G, there's a huge change because this certificate is now included in the signaling exchange itself as part of the core functionality of the 5G feature. Anything failing in terms of certificates will affect the real traffic that these network functions are handling. So it's just that 5G elevates the importance of the certificate management lifecycle.
Thank you. Let's see. Um, uh, so this question actually is specifically addressed to you, Jesus. Does automated, and I think this will be the last question that we take up today, which is does automated certificate management manage also the trust store and root CA certificates in automated way?
Mhm. Okay, yeah, this is related to this use case example that I was showing with the SEP and the roaming interface towards remote roaming partners. The automated certificate management capability can only handle the generation and renewals of your own certificates. When it comes to a roaming interconnection in the SEP, you also need to manage, as part of your trust store, the root CA certificates related to your roaming partners. And the way this is going to be done is that there is today there is a manual exchange, you will store it in your trust store, and you will need to do it for every roaming partner that you interconnect with, right? There are GSMA conversations on how to automate that. There is also aspects like automated remote self-discovery that could only have a proper behavior if the management of these root CA certificates is also automated in a certain way. So this would require some level of standardization, some guidelines from GSMA, so that the different operators and the different suppliers worldwide could take a similar approach, because otherwise the interworking will not work. So this is an area where we are also constantly following the industry and the GSMA conversations, but for sure there should be some future enhancement so that the management of root CAs related to roaming agreement interconnection can also be managed in an automated way. That's definitely an area to go for the near future.
Great. Thank you so much, Jesus, for this very, very insightful presentation. Very deep information about our cloud native platform and all the solutions. So, yeah, we are at the top of our mark. And thank you, everyone, for all your questions. So, as we come to the end of our session, I would really like to express my sincere gratitude to every one of you for taking that time to join us today, and listening in so far. And I highly recommend if you reaching out to us if you have any questions, and engage with us on our social media platform. If we have not answered any of your questions, we will reach out to you, and we will also be sharing the recording of today's webinar with you after we finish this webinar. And with that, I would like to thank everyone again, and have a great rest of your day. Thank you.
Yeah, thank you, everyone.
Bye.
Bye.